The exercise on this page is all about deciding what colour of solution would be observed dependent on the colours of white light that are absorbed. This can be used conversely when we get onto colorimetry, but I'll explain that then. To be able to do these exercises, you need to know this kind of colour mixing guide. Excuse the random colouring in, but my red ink on my printer is starting to die a little, so I've had to get out the colouring pens. You don't have this with you in the exam. You have this though, but they're not identical. Annoyingly, my picture's kind of the inverse of this diagram. But if we have a look at the two diagrams together, we can see that there is certainly some correlation. So looking at our red, which is up here, and in between our red and our green, which is down there, exactly halfway on this one, we get the yellow. The other two are a little bit more of an issue because the third primary colour of light is over here. But whereas this side has three different colours of light in between the red and the green, when you start including the blue, you're only getting given two colours of light in between, and two colours of light in between the blue and the green, which means that our exact in-between colour that we would be looking for would be exactly here and exactly there. So exactly in between our red and blue, where we know from this diagram we are getting magenta, magenta's not on this diagram, so you need to remember that that's where magenta would pop up. Likewise, in between our blue and our green, we've got cyan. So exactly in between our blue and our green here, we've got cyan, but it's not labelled on our diagram. So, having a look at the diagrams and having a look at the colours of light that are being absorbed here. I'll just fold this page so we can focus on the question that we're after. What we've got here is we've got our source of white light, and we're getting shown the three different primary colours. We've got red, green and blue light heading for this test tube. Below the test tube, it's telling us that cyan light has been absorbed. Now cyan light is directly in between blue and green, or over here, directly in between green and blue is our cyan. So cyan is the colour of these two mixed. And if that's being absorbed, then the only colour that can head through the solution that's not absorbed is red. So we would see this solution as red. In this next example, we've got, again, source of white light, the three primary colours coming through, but this time it's green light that's been absorbed. So that's this one going. So over here, if our green light is absorbed, then the colour that you'll see will be exactly opposite that. So we'd see a kind of magenta colour appearing. On the colour wheel, if green light is absorbed, then we would expect this magenta to go, but the one that we would choose in terms of the SQA would be the exact opposite colour, and we would say that the purple is the one that's visible because that's the one that's been transmitted through the solution. the last example, in our last example, it's saying that yellow light has been absorbed. Now yellow light is made from red or green, red and green, regardless of which of these two diagrams you look at. So that's yellow light made from these two has been absorbed. So the only colour not absorbed and therefore transmitted would be blue, and therefore that's the colour of solution that you would see.